Hey guys, welcome to the video lecture for Tuesday, September 22nd. And so we are still in lesson 2, and we are talking about technology and map making. And today we are going to talk a little bit about topographic maps. And you may have heard that, we may have mentioned it already. But just imagine that you're hiking and across the United States. You might want to kind of follow level terrain. Uh, but think about it. If you're piloting an airplane across the sky, you would definitely want to make sure that you're flying higher than a mountain so you don't crash into the side. So when we have a map that shows how high or low something is, that's a specialty type of map. So the word topography actually comes from two different Greek words. You get a little bit of a Greek lesson here. You have the word topos, which means place, and again from the word graphein or grapho, meaning to write or to measure. So topography literally is to write about a place. Now, when you have a map that's shows the detailed area of the Earth's surface, the detailed shapes, it's called a topographic map. So here's our vocabulary word. A topographic map shows the detailed shapes of Earth's surface along with natural and man-made features. It helps you kind of get an idea of what the landscape looks like without you actually being there to see it. So I want to show you here. This is here in this picture right here. This is it's called Devil's Tower, and then you have next to it over here a topographic map of Devil's Tower. So standing here from the side, you see it's relatively flat, not completely, but relatively, until you get to the base here, and then it shoots straight up. Now look at this area here. You can see the change in the surface. So it goes from fairly level, and then all of a sudden it jumps right up. So this is a map view. So remember, you're looking down from the top, but this is details that you're not necessarily seeing in the photo. Then you have what's called elevation. Elevation is the height above sea level of any point on Earth's surface. For example, Mount Rainier in Washington is 4,392 meters above sea level. Now, the city of Olympia, Washington, is about 43 meters above sea level. So that's elevation. Then you have relief, and relief is the difference between your highest and your lowest point in an area. So think back to Mount Rainier. The relief between Mount Rainier at 4,392 meters and Olympia, which is 43 meters, the relief is 4,349 meters. Now, on a topographic map, I'm going to go back here real quick, you see all these lines, these squiggles all the way around. These are called contour lines. Contour lines are lines on a topographic map that connect areas of common elevation. So think about, let's go back to our Devil's Tower. You have similar, kind of like our lines of latitude and longitude. They don't really exist in reality. You don't go and see these lines, but you can measure both the elevation and relief on a topographic map. So if Devil's Tower, our tower here, is 5,112 feet, and the base is 4,400 feet, what is the relief? Well, you'd subtract them again. 5,112 minus 4,400, and that's how you find your relief. Now, so let's figure out, when we look at these contour lines, what do they mean to us? It's one thing for you to see them on the map, but let's figure out what this information actually refers to. So when we're interpreting contour lines, we know that they represent something. It means something. So here we have some contour lines. This is kind of just a generic contour map that I had pulled up. So these contour lines here actually represent a mountain. So you notice that the elevation is not written on every single contour line. You've got it written on some, but then you have others where you don't really see anything. So these darker contour lines, where you see the elevation written, these are called index contours. So then we have this here, 1800, that's our contour, our index contour, and then you have this one here that says 2260, that's another one. How do we figure out this in between? How do we know what these lines are? So you need to know the difference in elevation between the lines. So elevation between different contours that are next to each other is called the contour interval. So that's the difference. That's just like, that's the relief, but only on a smaller scale. So we're not talking about the highest and lowest, but it's just the difference in elevation between those lines. So going back to our map here, we have contour intervals of, let's see, so that's 2,260, and this is 1,800. We've got a contour interval of 4,000 or 460. Now, so we find that first, this closest one here, so right around this one here, and we're finding the closest index contour to the contour you want to identify. So if we wanted to identify this one, then we say this is the one that's closest, and we count up to it by 50s. So if we wanted to say, what is this one here? Well, let's count up to it. So we've got 50, 100, 150, 200, 250. So this is going to be 250 less. So this is about 2010. So you notice that the contour line at the top of the mountain forms kind of a small enclosed loop. So you don't really see anything else crossing it. It just is there by itself. And then sometimes it has like a little dot in the middle. This one doesn't. This one just kind of has like this triangle shape there. You have kind of like that's the highest point. So here, this would be our highest point. Sometimes they'll tell you what the highest point in that in this particular contour is. Now the spacing of contours indicates what's called a slope. Now, slope is our measurement of steepness of the land. So let's look at this again. Here it descends pretty quickly, and then here the contours are farther apart, so it's a lot less steep. So we have different slopes happening here. So if the contours are spaced far apart, the change is gradual. If they're closer together like they are here, then it's steep. Now let's talk about topographic profiles. We read about the different map views and profile views back in lesson 1. So the information that contour lines provide on a topographic map can be used to draw an accurate profile of the topography of an area. So making profiles like this can help you determine the easiest path to take when you're crossing the land. So let's look at this map here. If you see, we've got a kind of steep area here. So this is a gulch, it says, and then we've got our mountain here. So if we're crossing this, we actually have some roads that are listed here. We're going to want to avoid the gulch. We're going to want to not climb up the mountain. So we work up our profile based on the topography here. Now let's think about the different symbols that you see on a map, on the topographic map. The United States Geological Survey has been responsible for mapping the U.S. since the late 1800s. So they've come up with a number of different symbols, and now they've changed over the years. And I have an example. This is kind of an older topographic map. Some of them are still the same. This is actually a newer one here on the right, but take a look at some of these symbols here. You have different contour lines, index contour here, intermediate contour. This is what's called a supplementary contour, and these are depression contours, so they go down. And so some of these are going to be the same, even in the newer ones. And then this one actually shows the different colors that you would see on the map and what they represent. And it gets pretty specific on this one here. They're not always going to be like that, but this older one gives you a lot of detail, and this one kind of gives a little bit more newer things, different buildings and things like that are sometimes listed on them. Green usually indicates some type of vegetation. So this gives you a little more listing what's like wooded marsh or mangrove swamps, shrubs, things like that. But the idea is that green is for vegetation. Water, obviously in rivers and lakes and oceans, that's going to be blue. That's kind of a no-brainer. You look at the map, you're pretty sure the blue part is the water. Now, again, so there's some updates, and you can actually go onto the USGS website, and I've downloaded a pretty big file. It's like 4 pages. You can read that. I'm going to post it in Schoology, so you'll have that you can look at on your own. But that's it for topographic maps.